All right, great. Welcome everyone. This is session 5 of Hack Sprint. Today we're going to be going over data and networking. So as always, here are the links to the slides and the README. Feel free to pull these up if you want to just follow along. The README right now, I think, hasn't been fully updated, but we'll get that done in the next day or so, hopefully. All right, moving on. Here's the link to the feedback form. As always, we really appreciate the feedback just so we can help make our workshops better. And there's also going to be a raffle for those who fill it out. So make sure to fill it out. We'll also link this at the very end. All right, in case you guys haven't heard, we have a new Hack Discord server, and you can join using the QR code on the screen. We have a whole bunch of channels that are just Hack Sprint related. So feel free to hop in there, and mentors and other people will just be there hanging out and also helping you with questions if you have any. Yeah, as a quick projects update, if you signed up to work on a project this quarter, just check the Hack Discord. We should have a channel there for you. And Nare has been posting a bunch of information in those channels. If you signed up for projects but do not see that channel, please let us know and we'll get you the right permissions to see the channel. All right, so today, as I mentioned, we're going to be covering data and networking. More specifically, some of the topics that we're going to be going over. I'm going to be going over HTTP GET and POST requests, URL session, APIs, Json, and Async Image. And then Thomas later will be going over databases and Firebase. So a quick note on coding along. We encourage you to try the things we cover after the workshop, but please don't code along just because we want you guys to actually get the knowledge down first. And the code will always be there later in the GitHub if you want to refer back to it. The README has all the talking points from the workshops as well, so you can use those as notes. And as always, ask us questions on Discord in the Hack Sprint questions channel. We'll help you out with any questions and problems that you run into there. Yeah, this sort of just a reiteration. Ask us questions if you're confused. Officers and mentors are here to help. All right, so as a quick intro to today's app, my part is going to be focused on creating a photo album. The photo album specifically is going to be of dog pictures. So you can sort of see from these two screenshots what the app will look like. So once you open up the app, it'll be blank and there'll be a title and a button to add photos. As you click the button, photos will be loaded onto the page. Just as a quick overview, I feel like this workshop is like really content heavy, but all the content is like super useful if you're going to actually be coding in the real world, and it's really applicable. So I highly encourage that you guys pay attention and refer back when you need to. All right, first of all, I'm going to be covering what is HTTP. So you guys might have heard this term, might have not. What HTTP actually stands for is Hypertext Transfer Protocol. For those of you who haven't studied HTTP, even me, my first time, I was like, what is this, right? If you want a quick translation, you can basically think of it as a way to transfer information over the web. Now, what does that actually mean more specifically? Well, HTTP is the language we use to communicate with a server. And a reason why we would use HTTP is, for example, to get a bunch of dog pictures, as we're going to do later in this workshop. Here's a quick diagram to sort of show how HTTP requests are made. So you, the client, can make an HTTP request to a server, and then that server will process your request and send back a response. We'll dive a bit more into what the types of HTTP requests are and things like that. So first of all, there is the GET request. As the name suggests, use this request when you're trying to get some information. So let's imagine I'm at the bank and I walk up to the bank teller. Something I could ask is, how much money do I have in this bank account? So that would be an example of a GET request where I'm making the request to the server. Now, the bank teller who is representing the server can have a few responses. So let's say like I gave them a valid account, it was my account, everything was good. They could just tell me, here's your balance and return me some information. So that would be the HTTP response giving you some information. Let's say that I'm trying to find out how much money is in an account that doesn't exist. Well, they'll simply just tell you that account doesn't exist. So this is also a thing if you are trying to make an HTTP request somewhere that doesn't exist, maybe to some URL or server that doesn't exist. And finally, there's also a case where, let's say I'm trying to view how much money Eugene has in his bank account. They'll probably tell me something like, you don't have permission to access that account. So similarly, some HTTP requests can come with authentication. So you can pass in some credentials in your request, and the server will actually check those credentials to make sure you have the right credentials and can see the information before sending it back to you. So this is the first type of HTTP request, the GET request. Another HTTP request that we have, or that is commonly used, is the POST request. So continue on with this bank example. Let's say I go to the bank and I want to deposit some money. I could send a request, which in reality would be like, can you update my bank account? Like, here's some money, could you deposit in the account? So that is an example of a POST request because I'm sending a request along with some information. So maybe like how much money I'm putting in, and then the bank will process that and update it on their side. So the server will take in that information and do whatever it needs to do with that. POST requests can also be used to generate some new information in a server. So this could be the equivalent of if I wanted to create a new account at the bank. I could give them some information about the account and then they can create it for me. So this is the second most, or I guess one of the most common HTTP requests, which is the POST request. All right, I realize I went through that pretty quick, but does anyone have any questions on what we've covered so far? All right, no questions. We can move along then. So we've covered HTTP requests, but how do we actually make these requests in Swift, right? Well, the way that you can make HTTP requests in Swift is by using URLSession. And specifically, URLSession gives you access to some of these tasks, as they're called. So the two tasks that URLSession has are two of the tasks that URLSession has. There's a few more that we won't cover in this workshop. One of them is the data task. So the data task is used for a GET request, and then the upload task, which is used for a POST request. I think the names are pretty self-explanatory, but let's dive a bit into each of them as well. So this is an example of what it really looks like from our app's point of view. We're going to be using a data task to get photos from a server. So us, the client, will send a request, something like, hey, can I get a dog picture? But it's in HTTP protocol, so they actually understand it. And then the server will just give us back the picture. Pretty simple. This is how the simple GET request flow works out. And the opposite is true for a POST request. I'll say something like, can you save this dog picture along with the picture? And I'll send it to the server. And then the server will process that and say something like, yes, the dog picture is now saved in the server. So this is how the upload task would work if you're trying to send information somewhere with a POST request. All right, now let's hop into the start of our demo. So here I just have like a plain Swift project. And on the side here, really small, I just put the reference of like what our app wants to look like in the end. So we'll get started setting up parts of our app, and then there'll be some content later that I'll dive back into the slides for. So just looking at like this small picture on the side, I do realize it's a bit small, but I had to fit it in the screen. Some of the stuff that you can break down. Well, first, there's a title, there's a button, and there's a bunch of images, right? A good way to contain all this would be in a VStack. So we can try that out. So in content view, here, let's define a VStack. And well, what's in the VStack from top to bottom, right? First, we have the title. So this will be a text view, and the text will just be photo album. And let's do some view modifiers as well, just to make it look nice. We're going to give it a font of .headline, and we're also going to give it some padding. Let's see how that looks so far. Not too much added in our app. In the meantime, while that's loading, we can start on the button as well. So the button will have some sort of text on the button. So in our case, if you look at the right side, it says add photo. And the button also takes in an action, which is basically the function that's going to be called whenever you click on the button. So I'm just going to leave this blank for now. We'll program that part in later, but let's just have the button here with some padding. Hopefully this loads. Okay, it does not seem to like me very much. Let me try switching to the simulator. Oh, okay. Go. Now it's here. Really simple so far. We have a text for the title, and then we have a button. So in some of the previous workshops that we did, we covered the Mvm model, which for those of you who might not remember what that stands for, it's basically splitting up your app into the model, the view, and then the view model. So in our case right now, the content view is a view since it just dictates what is going to be displayed, or like how it's going to be displayed. So let's also create some folders to store the other parts of our app. I'm going to create a folder for view, and this is just going to store like content view and the dog app Swift files. I'm also going to create a folder for the model, which we'll implement later, and also another folder for the view model. So if you guys remember, basically the view model serves as sort of an intermediary between the view and the model. So let's first put the views inside the view folder. So this is going to be content view and dog app demo. And then in content view, we're going to want to start creating that URL session. However, the URL session is sort of doing some more like processing, and it's not really dictating like much of the view. So we actually want to put that in a view model instead. So I'm going to create a view model file, and we're going to just call it dog pick view model. All right, so here we can actually create another class called dog pick view model. And we're going to have to make this class be an observable object. So what this means is that we're going to allow other classes to keep track of like this class and how it changes. The reason we need this is because in the view, we want to keep track of how the view model changes, because the view model is going to dictate the actual information. And the view is sort of displaying or changing how that information is displayed. So in our dogpig view model, we're going to create the URL session. So I'm going to create a variable called default session, which is going to be a URL session. You'll see here there's an autocomplete already there. I'm just going to hit enter in order to select it. But basically, the URL session is going to require a configuration. I didn't really cover this in the slides, but we're just going to use the .default configuration. Some of the other configurations can be used for other cases, like if you want to download stuff in the background, or if you want to do some other stuff, fancy stuff. But for our purposes, we're just going to use the default URL session. And we're also going to create a data task. And the data task is going to be of type URL session data task, but we're going to make it optional. So as a quick review of that, we're basically saying this data task can have a nil value, or it can actually be a URL session data task. Next up, we're also going to have an image or a list of dog images. So basically here, we're going to have a published var. So I'll type out the actual syntax and I'll explain it after. So what I have here is a variable which is named dog image list. And the dog image list has type array or list of strings. And it's going to be initially set to just an empty list. What published here means is that we're basically allowing the other classes to see how this variable changes. So whenever this variable changes, it will actually trigger whatever other class, in this case, the content view, to basically re-render what is on our screen. So this is important for later on. Whenever we're going to try to add a photo to the screen, all we have to do is add or just change this dog image list in any way, and it will basically like re-render our screen and add or take out images as we need. Okay, we're also going to have a function called getDog, which, as the name suggests, is going to get a dog picture. But before we get into that, let's go back and go into a few more things that we need before we can fully code out the functionality. So next up, let's talk about what an API is. So you might have heard this term thrown around a bit, but API stands for Application Programming Interface. That sounds confusing as well, but the idea is that everyone is basically writing their own code. And let's say I write some code and I want other people to use it. Well, I can create an API in order for other people to use my code. So one of the example APIs that we're going to be using today is the dog API. So here, I just have the home page loaded. You can sort of see like all the documentation and stuff if you want. But the important part here is we have this link. So if I copy paste this link into my browser, here what's happening is if I click enter, it's actually going to make a GET request to this URL, dog CEO, whatever. And what's being displayed here is actually the HTTP response that I got. So you'll see the response. It looks a bit weird if you haven't seen this format before. But yeah, this is basically how the API works, is you can make a GET request to this API, and then it'll return you some information. Okay, moving on. So sort of explaining that notation that you saw earlier, that's what's called a JSON. JSON stands for JavaScript Object Notation. And usually it is defined to start with a curly brace and end with a closing curly brace. So you'll see here, you have the start, which is going to be this opening curly brace, and you'll have the end, which is going to be the closing curly brace. Now, between those, you have what are called key value pairs. So if you look really closely, you'll see that you have quotation marks around message, and then you have these colons. And then after the colons, you have this other string. So in this case, it's like a random URL. So this is going to define a key value pair, where the part on the left is going to be the key, left of the colon, I mean, and the part on the right is going to be the actual value. So one thing to note here is that the key always has to be a string. So it could be any string that you'd like, but it always has to be a string, while the value can be other types besides a string. So you could have it be a string, you could have it be an integer. There's a lot of values that it can take upon. But yeah, this is a really simple demonstration of a JSON. If you go back to the browser webpage, let me zoom in a bit so you can read this. But what you'll see here is there's going to be two key values that are returned. So the first is going to be the message key, and then the value, which if you copy paste this link and put in your browser, which makes another GET request, it's basically just going to have a picture of a dog. And there's also a key value pair for the status and success. Just to show you guys that this API is like random, it gives you like random pictures. I can refresh this page and it'll basically give me like different URLs every single time I refresh. But yeah, after that, we have a quick poll just to make sure that you guys are following along. So let me start that really quick. All right, so the poll should be launched. Let me know if you can't see it. I'll give you guys maybe like a few minutes to fill this out. It shouldn't be too challenging, but it will give me like a better gauge of how closely you guys are following along with the information. I'll be sure to go back and cover any parts that may be confusing. All right, I'm gonna close the poll in 5 seconds. 4, 3, 2, 1. All right. So it looks like some people were a bit confused on the HTTP requests and also a bit on the URL sessions. It looks like you guys are good on JSONs, which makes sense since we just covered it. But I'll just go back really quick and review the parts that may have been confusing. So starting off with HTTP requests, there's many types of HTTP requests out there, but the two that we're going to be talking about specifically in this workshop are the GET request and the POST request. So really simply, the GET request is used to get information. The POST request is used to send information to a server. So there's many others out there if you want to look into it. Feel free after the workshop. And next up, also URLSession. Let me go over that really quickly again too. So URLSession in Swift is used to make HTTP requests. And it does this by giving you access to some tasks. So there's going to be the data task, which can be used to make a GET request. And there's the upload task, which is used to make a POST request. All right, let's move on. So here, let's now talk about the URL, specifically the URL in Swift. So within Swift, the URL refers to a struct. Notice it's not a class, but the struct stores a URL. Okay, that might be confusing, but let's look at like this example down here. So here, what I'm doing is I'm creating a variable which is named lowercase URL, and then I'm setting it to this URL struct, and the URL struct takes in a string, the string being the actual link that you want it to be set to. So in this case, I just have it set to the hack website, but you can set it to anything you'd like. In fact, I believe you don't even have to set it to a valid link. The URL struct also helps break down parts of the URL. So this is not relevant for our workshop, but if you ever have a URL where you also have to send like parameters, things like that, it'll also help break that down for you so you can easily access them. One thing you'll notice though in this line is that at the very end of a line, I have this exclamation mark or the bang symbol, which if you guys remember, it basically forcibly unwraps an optional. So what that means is an optional may be a nil value, or it may be, in this case, the URL. However, when I add this exclamation mark or bang, it's basically saying I always want to make it into a URL, even if it's a null character. The problem with this, however, is that it's pretty unsafe if you have it in your code. If you know that this URL is valid, by all means, go for it. But let's say that the URL is not valid. What will happen actually is that your code will run into an error, possibly crash, and that's not good. So let's have a quick Swifty time in order to tell you guys how to solve these sorts of optional unwrapping problems. Yeah, so this is a quick segment on how to not crash your code. So there's three main ways to deal with optionals in a safer manner than just using debang. So the first of them is optional chaining. So basically what optional chaining means is only do this if the value is not nil. So these are some sneak peek lines from the code that we'll write later. But if you look at the first one, I basically wrote data task question mark and then dot cancel. So you're probably used to seeing something like data task dot cancel without the question mark. But basically the question mark here says, I only want to call the cancel function if the data task is not nil. And if the data task is nil, I don't want to call that function. So this is really important because if the data task is nil and you try to call cancel, it will run into an error. So in this case, it's basically helping you do that check and calling it if necessary. The next one is going to be optional typecasting. So this basically is going to cast if it is possible to cast, or else it will just be set to nil. So once again, I think the example illustrates it perfectly. So here we have a response variable, And let's say that I want to cast the response variable to an HTTP URL response. If you never heard the word cast before, it basically refers to changing a variable from one data type to another. So for example, maybe like changing an integer to a float value or something like that. But in this case, what we're trying to do is we're trying to cast the response to an HTTP URL response type. However, we don't necessarily know if such a casting is possible. Let's say like response is actually an integer. Well, an integer can't be cast to an HTTP URL response. That just like doesn't make sense. So in this case, what's going to happen is this right side here, response as question mark, HTTP URL response. It will cast the response if it is possible and return that, or it will just be set to a nil value if the cast is not possible. So this is also a safer use case instead of just trying to force the cast into a HTTP URL response. If the cast is not possible, it will break your code as well. And finally, yeah, I didn't update this title, but it should be optional, like trying. So basically, ignore the typecasting. What's happening here is we basically want to try to do something, and we only want to try to do that if there's no error. So here we're trying to set a response to Json Decoder.doStuff. Just ignore the try for now. Let's say we just have the line response equals Json Decoder.doStuff. In that case, the Json Decoder.doStuff function might run into an error. And in that case, we don't necessarily want to set response to whatever gets returned by this right side. However, this optional try basically just lets you set the value only if there is no error that appears from Json Decoder.doStuff. So this will be used later as well because we'll be decoding a JSON. So you'll see that in action later. All right, I realize I went over a lot more content. So does anyone have any questions on what we just went over? Okay, looks like no questions. So let's go back to the demo. Let's actually write out the functionality of getting this dog now. So the first thing that we're going to want to do, if we're trying to get a dog image, is we want to check if the data task is currently doing anything. So the reason why we want to do this is if the data task is already busy, we don't want it to, we don't want to try to make it do other things. So we can just simply handle all of this by canceling whatever the data task is doing currently. So that's going to be the first thing that we're going to want to do is if the data task is already executing something, just stop whatever you're executing. And next up, we're going to try to create the URL. So if you remember, it looks something like this. Let URL equal URL, where the string is going to be something. So let's actually create a variable for the API URL. That way later, if we want to change the API URL, we can do that as well. Just going to go to the dog page and copy this right here. So after we have this URL, we can pass it into the URL struct. And keep in mind, this URL is optional as well. So we want to check that by using the if-let syntax that we showed in previous workshops. So in the case that this URL is valid and it gets set to this lowercase URL variable, what we're going to want to do is set the data task to default session, which is our URL session dot data task. And you'll see here, there's already a completion with URL. So in this case, we're just going to pass in our lowercase URL variable here. And this function is actually going to also have a closure. So closures are something we went over in a previous workshop as well. As a quick recap, basically this closure function is going to be called whenever this other data task function is done running. So here, this closure specifically is going to take three parts or three parameters. So it's going to take data, response, and error. So these three parameters are actually going to be returned by the HTTP response that we get from the server. So just to make sure that our response was good and we didn't run into any problems, we're just going to do some checking. So this is going to check if we ran into an error. If let error equals error. I know the syntax looks a bit weird, but this is basically saying if we can have an error which is not a nil value, then we basically are going to execute whatever is in these curly braces. So in the case that we do run into an error, well, let's just return, which basically ends the function right there. And otherwise, let's check that the data value is not nil as well, using let data equals data. Same with response, let response equal response. And specifically, we want to also do that optional typecasting with response that we covered in the slides. So it's going to be HTTP URL response. And we also want to check what's called the response status code. So when you get a response through HTTP request, there's going to be a status code associated with it. So if you've ever seen something like a 404 not found error, that's like a possible status code. In our case, we want to check that the response status code is 200, which basically means okay, like your response was good and your request is good, all that. So in the case that all of this is good, the data is good, response is good, then let's actually try doing whatever we need to with the data. So we're going to try to basically decode the JSON data that we get. We're going to be using the Json Decoder that is built in to Swift. And specifically, we're going to be decoding the data. So it takes another parameter, which I'll leave blank for now, but it's going to be decoding from the data. So this parameter that I left blank, basically what Swift wants you to do here is it wants you to pass in a struct that matches the format of the JSON that you're trying to parse. So that sounds really confusing. Let me go back and show you what I mean. So here we see we have this JSON. There's two key value pairs, as I went over earlier. So there's a message and there's also a status, and they both have values as well. Both the values here are actually strings. That's important to note as well. So let's start by creating a model, because this is something that's sort of like in the backend used for processing. So we want to contain it within the model. Specifically, I'm going to call it response, because that's just going to be the name of the struct that we have in here. So here, I'm going to define a struct response. And we have to make sure that this response is of type decodable in order to allow it to be passed into the JSON decoder. And now I'll show you like how that mirroring of the JSON format works. So if you remember, we have two key value pairs, one for message and one for status. And we can also define the type that is going to be the value. So if we have message and status, the types for the values are going to be string, as we saw earlier with the JSON. So now that we have this response struct, we can actually pass it into this JSON decoder. So the way that we're going to actually pass it in is response.self, which basically like tells it to use the type of response. And once again, we're going to try to use one of the safer optionals. So we're going to want to try to do this. And if not, this will just return a nil value. Let's actually set it to a variable. So something like if let response equals try. This looks really complicated. Let's break it down. What this is saying is we want to try doing this JSON decoder stuff. If it works, great. Let's set that value into response. And this if let only will execute whatever is in these curly braces if response actually gets set to a value that's not nil. But if the JSON decoder doesn't work, this optional try is going to set the value of response to nil. And since we have this if let here, since response is nil, we're not going to execute what's in the braces. Okay, so now that we know the response got decoded as well, all we're going to do is we're going to take dog image list and append, or basically add to the end of the list. What are we going to add? We want to add the response.message, because this is going to be the actual URL for the image that we want to show. And finally, we've defined this data task, but we also want to tell the data task to start. So what we're going to do is we can write data task, once again with this optional dot resume. All right, so now that we have our view model set up, what this view model is going to do is every single time we call the getDog function, it will add a string, which is going to be the URL of the photo that we want to render into this dog image list. So now that we have the view model set up, we can go to the content view and actually call the function. So within the content view, we're going to create an observed object. So if you remember, we also defined that this view model is an observable object. That's because we want to basically monitor the changes in the view model. So we're going to call it something like dogpic VM for view model. And we're going to set it to this view model. And now whenever we click the button to add a photo, here the action will be self.dogpicvm dot get dog. All right, so we've implemented the function into the button, but now we actually want to like display all of the pictures as well. If you remember from a previous workshop, something that we did is used the list, breaking down the list in order to render an image for each element in the list. We're going to do something similar to that here. So the list that we want to break down specifically is dogpicvm.dogImageList. If you also remember from that workshop, we made sure that the list, or not the list, the struct had an ID, because we need an ID in order to use this breaking down the list. However, in this case, since our dog image list is just like strings, we don't necessarily have a struct with an ID in it. So instead, we're just going to use ID equals \self. This basically uses like the ID that Swift already has for each of the elements. And then let's just say we want to refer to each of the elements as we're going through them as dog. And here we're going to usually want to use a photo, but we actually have a special type of view that we're going to be using for this demo. So as a quick background, Apple every year has this event called the Worldwide Developers Conference. And in the 2021 edition of this event, they actually revealed this new view, which is called Async Image. So Async Image is a new view that's only available in iOS 15. And the whole premise is literally just to show images from links or URLs, as we mentioned earlier. The overall biggest benefit to Async Image is that it's asynchronous. So what does that actually mean? Well, you've heard the term asynchronous in the past, probably because of something like an asynchronous class. Well, a class is called asynchronous because the class itself doesn't have to necessarily take the time up in your schedule there. So you can sort of choose whenever to watch the class. It doesn't block the other classes that you might already be taking. So similarly, asynchronous in code specifically refers to when code can be executed without blocking other code. So how that actually is going to play out in our app is, let's say that we want to basically load an image from a URL. Well, in order to do that, we're going to have to make a GET request. We're going to have to wait for the response. It may take some time. And while we're trying to make that request, we don't want to basically hold up the rest of our app. So without an async image, if you were to click add photo, your app would basically be frozen and you wouldn't be able to see anything because you'd have to wait until everything was fully set up and ready to be displayed. However, with async image, whenever you click add photo, you can actually keep the rest of your app still going, and only that asynchronous image will load sort of asynchronous with everything else, meaning that it won't block any of the other code or things you have going on in your app. So let's go and try to implement that. So here, instead of having a regular image view, we're going to have the async image. And the async image, as the completion suggests, it's going to take in a URL. And we're just going to be using the URL from the string dog. Dog, since it's the element in the list, will be the URL that we're trying to access. So here, we're just going to pass that in. Using new view modifiers on this async image is a little bit weird. You have to use another closure here. And specifically, we can edit the image by writing image in image. And then here we can apply the regular view modifiers to this image variable. So let's say we want the image to be resizable. We can do that. Let's say we also want it scaled to fit or fill, I mean. So I've already sort of styled the image beforehand. That's why I know how to write all of these things. But when you're actually coding, you can sort of play it by ear and see how you want to style your images, things like that. Here I have this frame with max width .infinity. This doesn't actually mean that I want to be able to have an infinitely big picture. What this means is I want to be able to take up as much room as possible. So in this case, the bounds of this image are actually going to be determined by the view that it is in. So in this case, in the list and VStack. So I'm just going to do some styling here. And the cool part of the async image is the fact that we can also have a placeholder. So in this case, all you have to do is write placeholder. And then within these curly braces, you can define what placeholder you want. There's a cool one that's called progress view that we can use. And now let's actually try out the app and see if it works. So I'm going to build it on the simulator. To use the simulator, use the like preview is because the buttons don't work on the preview as we've seen with like some of the other workshops. Oh, sorry. But yeah, give it a second to load. All right, so now we have the title, the button, and when I click this button, you'll see that there's a brief placeholder there, and then it'll pop up with a picture of the dog. And I can keep clicking this button, keep generating dog photos. And yeah, that's pretty much my part for the demo. Oh, sorry, I said demo here to go back to the demo. But yeah, I believe we have a checkpoint poll here. So I'm just going to launch that really quick as well. This is basically just asking about the pace and things like that. Okay, I'll give it like 5 more seconds. 4, 3, 2, 1. All right. So it looks like the speed was like just about right. But yeah, let us know if you have any questions or you're still confused about any parts that I covered. Now we're gonna have a quick break. Oh, the comeback time will not be 7:16. It'll actually be 7:08, I guess. We can take a 10-minute break. But yeah, feel free to ask in the chat or on Discord if you have any questions.
Hi guys. Hi guys, my name is Thomas McGall, and I'm also a part of Hack. And today I'm going to be teaching you guys about Firebase and Firestore. So right now we have a problem with our app. What if we have a couple of dog pictures that we like and we'd like to keep them, but we have to close our app? Right now, if we close our app or move to a different phone, we're going to lose all of the dog photos that we pulled from the API. So the question is, how do we transfer these photos from one instance of an app to another? And we're going to do that using a database. So what is a database? A database is an organized collection of data, and each database has its own data model. Data models are different in between databases, but it's basically how that database chooses to organize its data. Databases can either be online or locally stored. And the benefits of having a database that's in the cloud is that it's accessible through the internet, which means that we can send information to this database and pull information from this database through the internet. And like an advantage of that is it allows devices and apps on different devices to communicate easily. So once again, why should we use a database? Specifically in the case of our app, well, a cloud database has something called persistent storage. This means that if we close the app or if we move devices, this storage is going to be persistent and it's going to be there when we want to update our app with the dog photos of our choice. So once we implement this database, we'll be able to figure out which dog pictures we want to keep, and then we'll be able to keep them. So this is kind of what we'll be doing instead. We have this picture of a beagle. I really like beagles. And we're going to upload this picture of a beagle to the cloud, a database stored in the cloud. Once again, that means on the internet. And we're going to pull that picture of a beagle back onto our phone, either if we open the app a second time or if we're on a different device. The database that we're going to be using in this workshop is called Firebase. And Firebase is a cloud database service. It's backend and what is backend? Backend is basically what happens behind the scenes of an app. This includes a lot of things, but one of the things it includes is storage and how we're keeping our information. Firebase is super useful because it allows developers to easily link their applications to cloud storage. So Firebase has a lot of different services. The one that we're going to be using today is called Firestore. And Firestore is, once again, a cloud-based backend database. And the benefits of using Firestore, rather than keeping our own server or something, is that it's outsourced to Firebase, which is owned by Google. So we don't have to worry about a lot of things like load management, or we don't have to undertake the costs of hosting a database. So Firebase and Firestore are super useful. So now we'll talk a little bit about Firestore's data model, which is unique to Firestore. So it's document-based. The two things that are most important for understanding Firestore's data model is documents and collections. Collections are groups of documents, and documents each hold a series of key value pairs. So we'll take a look at how this looks in the Firestore platform. So here we have a collection. If we want to store a group of dog pictures, we'll call this collection dog pictures, for example. And then Firestore will give us a series of auto-generated names that we don't have to come up with. And this is useful because they're guaranteed to be unique. And when we're accessing data or writing data, our program won't get confused about what we're looking at. And within each of these documents, here are the key value pairs that I was talking about. Specifically, the keys are referred to as fields. In this case, since we're going to be storing a series of dog picture URLs, I'll have one field called image URL, and you also specify the type of the field. So this one's a string, and it will store a URL to a dog image. Another interesting feature about Firestore's data model is that you have these things called sub-collections. And this would be useful if you were writing an application that had like user logins, member logins. So you could have a document that represented a specific user, and then another collection with more documents that could, for example, hold dog pictures. So right now we'll have a quick poll just to check our understanding of what we've gone over so far. Eugene, do you think you could help me post the poll? Okay, thank you. Okay, the responses are looking pretty good so far. I'll just go over what we put so far. So first question, what is stored inside a Firestore collection? The correct answer is documents. Everyone got that one right. The next question, true or false, file storage is local storage. This is false. File storage is cloud storage, which is what makes it so useful. So now we're going to start setting up Firebase in our Xcode project. Firestore and Firebase make it super easy to do this. So there's two things we're going to have to download or update our project with. The first is a config file that Firebase is going to provide to us, which basically tells our project like where to write and read data from. The next thing we're going to have to install, and we're going to go over how to put this into our project. The next thing we're going to install is the Firebase Sdk, which is basically a series of classes that allow us to easily interact with the Firestore database. And there's a number of ways we can install the Firebase Sdk, but today we're going to be using Cocoapods. Well, what is Cocoapods? Cocoapods is a dependency manager. That might sound a little confusing, but basically what that means is that it allows us to use external libraries. And in this case, it's going to allow us to use the Firebase Sdk. And this is basically Cocoapods giving Firebase to us. So we're going to go through all of this in a demo in a moment, but I'll just give you guys a quick overview of what we're going to be doing. So these are some of the commands that we're going to be using to install the Firebase Sdk. Basically, first we want to install Cocoapods, and then we're going to navigate to the project directory that we're working in. And then we're going to do pod init, which is going to create a pod file. And then we're going to open the pod file. And then under where it says pods for, and then our project, we're going to put this line, and then we're going to run pod install to update our project. So one important thing to note is that Cocoapods will not work properly if you installed it like this on an M1 Mac. So here are a couple of codes that we're going to be substituting if you want to install Cocoapods on an M1 Mac. And it'll be pretty clear once we do our demo where we're going to be substituting these in. So now we will get started with our demo. So the first thing you want to do is we want to go to firebase.google.com. If you've never visited the Firebase website before, it'll probably say something like get started, a big get started button around here. And you can click that and it'll take you to a page that looks like this. So let's create a new project. We're going to click on add project. And we'll name this one dog app workshop. Cool. So it's going to ask you if we want to use Google Analytics for our project. It can be useful, but since this is just a small project, we're going to not enable Google Analytics for this project. And it might take a little bit to create that project. So now we're in our project, and the next thing we're going to click, since we're working on an iOS app, we're going to click this button right here that says iOS. And here it's going to ask for Apple Bundle ID. And we're going to find this in our project. So here I have what we've built so far in this workshop. And we're going to go right here, and where it says bundle identifier, we're going to take that and we're going to copy that into where it says Apple Bundle ID. These other two ones are optional, so we're just going to ignore them and click register app. Okay. The next thing we're going to do is we're going to download the Google service config file that I was talking about earlier. So we're going to download that. and I'll just put that on my desktop right here. And we're gonna want to drag that into our project. So I'll open up our project here, and inside, I think, okay, inside right under assets, we're going to want to drag our config file and drop it in, or sorry, we can just drop it directly into our project here. We'll put it in right beneath assets. And when you do that, you want to make sure that this line right here that says copy items if needed is checked, as well as add to targets, and then the app itself. So now we have a config file in our project. Next. So now we're going to get around to adding our SDK to our project. The first thing we're going to want to do is we're going to want to open terminal. I have it open already, and we're going to want to install Cocoapods. So I already have Cocoapods installed, but if you didn't, you type sudo gem install and then Cocoapods. It takes a long time, so I'm not actually going to do it in this workshop, but that's the command you would use. Once that's done, you can check that it works properly. You can check that it worked properly by typing pod -- version. So I have a fully updated version. You'll probably see a number like this if you properly installed Cocoapods. So now that we have Cocoapods installed, also, sorry, this is the part where we would want to substitute these commands, since I'm on an M1 Mac. So these are the commands that I used. So once you have Cocoapods installed, the next thing you're going to want to do is you're going to want to navigate to your project directory. And if you're not familiar with terminal commands, CD stands for change directory. And I'm going to try to work my way into my project directory. So I'm first going to go to my desktop, and then I'm going to go to my project, which is called dog app workshop. Dog app Firebase workshop. I'm changing directory to dog app Firebase workshop. So now that we're in it, we're going to run the command pod init. So if that ran correctly, when we open up our file, we should see something called a pod file in our project directory. Okay, so then we're going to have to edit this pod file in order to bring our SDK into our project. So if you look up available pods for Firebase, it's going to give you this list of different services that Firebase hosts. The one that we're going to be using is called Cloud Firestore. That's what we're talking about. So pod Firebase / Firestore. We're going to go back. We're going to open up our pod file. And right underneath where it says pods for the name of our project, we're just going to put pod Firebase Firestore. We'll save that, I'll close it. And then we're going to go back to terminal, and we're going to run pod install. This might take a second, but hopefully not too long. Okay, so it worked. If it didn't work and you got some errors, it's likely that you didn't properly install Cocoapods. For me, the first time I ran this, it didn't work just because I didn't account for the fact that I was on an M1 Mac. So yeah. So now our SDK is in our project. And one last very important thing to note is that it says it right here in small text, but it should really be bigger. Oh, the next one. Anyway, you have to use the Xcode Workspace. If you use the Xcode project going forward, it won't work. So make sure from now on, when you work on your app and try to build it, you're opening the workspace. So I'll just close this project. I'll stop the build, and then let's open up the workspace with Xcode. I'll start the build right now just because it takes a while to compile the first time you download the Firestore Sdk. And let's continue. Okay, so there's one last thing we have to do to finish our setup. And we have to add these two lines, import Firebase and firebase.configure. And we're going to add those into our project inside of our app. So right here, we're going to import Firebase right under where it imports Swift UI. And then we're going to do an initialization function that is going to configure our Firebase. So Firebase configure Firebase app.configure. Now our project should be able to use the Firebase SDK to interact with our database. So now that we've set up the Firebase SDK, let's set up our Firestore database. To get there, we're right now at our project directory. We're going to go to this column on the left, and we're going to click Firestore database. The next thing we're going to want to do is click on create database. And here we have two options. We have production mode and we have test mode. Production mode has a lot more security features that prevents certain people from writing or reading information from your database. But since we're not publishing this app, we can just do start in test mode. And then for location, you're going to want to select the closest time zone. I'll just do this one since it's default. And this might take a second as well. Okay, awesome. So now we see something that looks similar to what we saw in the slides before. We're going to make a new collection. Since we're storing a group of dog pictures, we'll just name it dog pictures. And then for document ID, we'll just do auto ID because we want to make sure that each of these IDs are unique. And then for our fields, since we only really have one piece of data to store for each of our dog images, which is the URL, we'll just do image URL. And then here you can select the type of field for the type of value that you're storing. And for us, since it's a URL, it'll be a string. And here we would put an URL for a dog image. So we'll just put one for starters. What's a cool dog? I like Shiba Inus. And okay, we'll do this one. And then we'll copy the image address and we'll just put it into our first. Oops. Sorry. I don't know why it's not letting me save. Let's do another one.
It might be because you have the same. Oh, never mind. You're good.
Okay, I fixed it. Awesome. So now we have dog pictures, we have one document, and we have our image URL. Awesome. So now we can get started with writing code and figuring out how we're going to write data and read data and even delete data if we have enough time. Let's go back to our slideshow. I covered a lot of information really fast, but if you guys have any questions, feel free to ask and I can try to answer them as best I can. Okay, cool. No questions. So this is just a reiteration of what I said before. We're not going to be using the Xcode project anymore. This does not include the pod file that I was talking about. We're going to be using the workspace. And then this is just the initialization code that I typed up a minute ago. Okay, I'll just do a quick run through of what I'm going to be doing in the next demo, and then we'll get right to coding. So the first thing I'm going to do is I'm going to create a new model that reflects the values stored in each of our documents in our database. So we're going to want to make sure we have an ID to make sure we can identify each individual document, and then also an image URL, which just holds the image URL. If you can see this keyword identifiable here, this is something that we covered in last week's workshop. But basically, it just means that it's ensuring and enforcing that each of these dog pictures are unique objects. Later on, I'll be using two different functions that are pretty useful, but I don't think we've covered them yet in this course, so I'll just go over them quickly right now. We have map or .map, which basically iterates through a list, and for each element in the list, it'll perform some sort of operation on that element and then return an array or a list of all those altered elements. And then for remove all, this is another function that we will use on arrays and lists. And for all of, okay, so it'll run through this closure, and for all elements in the array that return true for whatever you decide. So in this case, it's if the dog pick.id is equal to the dog pick that ID of the dog pick we want to delete, it'll delete those elements. So when we want to read data, there's more to it than just this, but this is an overview of some of the most important elements. The first thing we're going to want to do is we're going to want to create a variable that allows us to access our database. That's right here. DB stands for database. And then to read data from our database, we're going to specify the collection that we want to access. So in this case, it's dog pictures. And then get documents is what we're going to be using to actually look at the different documents in this collection. It stores all of those documents in a snapshot right here. And then, so once get documents is finished, it runs this closure, which involves snapshot, which is basically just a snapshot of what our collection looks like, and then error if there are any errors. For reading data, it's a little bit similar. This has some of the stuff that we're going to go over during the demo. But so if there are no errors, so if there are no errors, dispatch queue.main.async is something that we don't really have to worry about. We do need it, but we don't necessarily have to understand it. It's a little complicated, but basically what it means is that our main thread is the one updating our user interface. That might sound a little confusing, and that's okay. You don't really need to understand it. So now, if we have a list variable, we're going to iterate through this snapshot, which contains all of our different documents, and we're going to return a dog picture that has the ID of the document that we're looking at, as well as the image URL, which was stored in the image URL field within our document. For writing data, it's a little bit similar. But instead of get document, we're going to be using something called add document. So once again, we create a variable that lets us access our database. And then we look at our database, the collection of dog pictures, and then we will do add document. And it's going to add a document with a generated unique ID, as well as a specified field, and then a data value for that field. And then once again, it stores, if there are any errors, it will store that in this error right here. And then if there are no errors, we're just going to call the get data function and update our locally stored data that we pulled from our database. So now we will start our demo. I'll just do a quick break for questions again. We're covering a lot of information, but I just want to make sure that we're able to get through everything. Okay, sounds good. Okay, let's go over to our project. So in our model folder right now, we have a response. And this is good for storing information that we're pulling from the API. But now, since we're looking at Firestore documents, why don't we create a new model for those dog pictures? So we'll make a new Swift file. And we'll call this one dog pic. Okay, so similar to the last one, we'll do this is in the slides also, if you guys want to look back for reference. And once again, we're using the keyword identifiable to make sure that all of our dog pics are unique. We're going to have an ID, and we're going to have an image URL. Okay, so now we have this dog pic struct. Let's take a look at our content view. Let's update all this information so that it'll start reading from our Firestore database. So right now, our view model Oh, this is our content view, my bad. So right now, our view model is an array of strings. But instead of strings, it's better if we have an array of dog pictures of this struct. So let's change this to, sorry, instead of this, it'll be dog list equals an array of dog pics. So now if we go back to our content view, or you can already see we have a bunch of errors, which is predictable, but we'll get to those in a moment. In our content view, yeah, so here are our errors. This will be the first thing we'll update. So if you look at what we have so far, we have self.dogpic vm.dog image list, and then ID of self. So since we declared our dog pictures to be identifiable, our program already knows that they're unique, and we don't have to specify this parameter anymore. Also, since we can just get rid of self as well, because we can just reference the dog pic array directly. The next thing is it says dog. So previously dog was just a string, but now since we have a dog pic struct, we're going to have to access the image URL key in order to get that picture. So dog.image URL, and that should fix the issue. So there's one more thing we're going to add, and that is another init, just to make sure that when we open our app, that our dog pictures will be automatically updated from what we have stored in our database. VM dot and then get data. So we haven't implemented get data yet, but we'll do that right now. So only here. Okay. So we have an error right here that says it's having issues appending. In a second, we're going to change that to get to data, which we'll write right now. Okay. And our function will take no parameters since it's not writing anything or looking for a specific document in particular. Like I said before, the first thing we're going to do is create a variable that'll let us access our database. Store. And then we're going to access the specific document we're looking for. It's called dog pictures. And then, so we have an error, cannot find Firestore in scope. That is because we forgot to import Firebase, and that should fix that. Yeah, so now we're looking at the dog picture collection within our Firestore database. And we're going to use the get documents function. And we're going to double click on this right here to open up a closure, which is going to allow us to do some of the things that I was talking about in the slides. One is to iterate through the snapshot of our database, and then also allow us to consider errors if there are any when we try to pull information. So we'll have two cases here. We'll have one if there are errors and one if there are no errors. So if there are no errors, we'll update our database. And then otherwise, if there are errors, we'll handle the errors. We'll skip that just for an extra time. But if you wanted to like print out the specific code of the error, you could do that in here. The next thing we're going to do is we're going to do if.snapshot. So if let is also something that we covered in previous workshops as well as earlier in this workshop. It's just going to, in this case, just make sure the snapshot exists. And then we're going to do the thing that I said before, the dispatch queue thing. Just make sure you have it basically. And then inside of this, we're going to be updating our array of dog pictures with whatever we pull using get documents. So we're going to return, so we're going to map through this snapshot and then return dog pictures that correspond to the documents stored in our database. So self.dog image list, and then snapshot documents. So the documents in our snapshot, and then we're going to map through that. And then for each dog for each document, we'll return a dog picture, and then we'll set its ID to the document ID of that document. So we can access that using .document ID, and then the image URL will be it'll be the image URL of whatever is stored in the image URL field. So documents, and then okay, yeah. So image, it's gonna look for the image URL field. So image URL. And then we're gonna use the as question mark thing again to make sure that whatever is returned from this image URL is a string. And if it isn't a string or it doesn't exist, it'll have some sort of optional default answer. So as a string, and then otherwise, it'll just set it to an empty string. Oh, I forgot the pin. Okay, so now our get data function should work. So we still have this error down here when we're trying to append these messages that we get from the API into our dog list. So we're just going to replace that with our get data function instead. So we'll do self again dot oh, never mind. Oops. Here, since we're running out of time, I'll just go over the add data function as well, just quickly. So now that we can get data, let's make another function for adding data. And this time it will take a parameter since we are specifying exactly what we want to be added into our database. So image URL. And then we're going to specify the string of the dog picture that we want. So once again, we're going to create a database, or we're going to create a variable that lets us access our database. Firestore. So again, we're going to specify the collection that we want to access. Pictures. And then instead of get documents this time, we're going to do add document. And then here it gives us an example of like the fields that we want to specify. So for this one, it'll be image URL. And then the value that we're going to be passing in will be this right here. So image URL. And then we're going to open up another closure here because we want to consider errors once again. So do error and then if there are no errors, you will just update our data. So we'll call our get data function. And then otherwise, if there is an error, we'll handle that error. So now that we have another function for adding data to our database, we can fix this error right here. So instead of appending these strings directly into an array of strings, we can take that string, create a dog pick struct with that image URL, and then we can add that information into our Firestore database. So we'll do self.add data, and then the image URL will just be the response.message that we're getting from the API. Let's get rid of this. Okay, so no more errors in view model. Dog pics all good. Content view. And that error is gone as well since we defined our get data function. So now I believe that this should work. Let's try building it. Uh-oh. Oh, shit. Oops, sorry. There's one thing that we forgot to do in installing our Firebase Sdk. And that was running, did we run pod install? Couldn't find valid. Huh.
Do you want to check your the actual folder in Finder?
Yeah.
Okay.
I have the Firebase.
It's looking like there's a 1 in front of the P list. If you scroll back up, that might be.
Okay. Let's try that. Let's try building that again. Thanks, Eugene. And we have an error. Okay, that's because we have to rename this as well. Yay. So as you can see, so let's take a look at our Firestore database. And this image that we put in here in this document is now being displayed in our app, which is awesome. If you want to add a photo, the API still works and it'll add a photo, and this time it'll be stored in our database. So let's add some more. That one's funny. We have a bunch of dog photos now, and as you can see, they're all stored in here. So like for this one, for example, I don't know if I can copy this. That takes us to this picture right here. Isn't that cool? So now we've built our dog app that successfully uses both URLSession and a Firestore database. So that's my demo. And I went over a lot of information. If you didn't get all of it, we're going to update the README after this, and you can follow what we did in our demo. But if you guys have any questions right now, feel free to ask. Oh. Okay, cool. So here's one more slide on deleting data. This is something that we can also do. Alessandra does like an extra challenge for you guys to try to do. The solution will be in the Git repo that we're going to update, but basically just try to add some functionality to delete the dog pics that you don't want. And you can do that using something that looks like this with other things. So now we'll do a checkpoint poll just to see how you guys felt about what we covered today. Okay, sounds good. Thank you guys so much for coming. Please fill out our feedback form. Links right here. Can someone put that in the chat as well? It's great to hear your feedback. Hearing how we did helps us improve upon our further workshops. And speaking of further workshops, next week we're going to be having our first work session where you guys get to work on your projects. In addition to the work session where we will all be to help you on your projects, we're going to be having a mini talk. And once again, it'll be taking place on Wednesday at 6. That's it. Thank you guys for coming. We'll stick around for a little bit if you guys have any questions.